Right now, as you're watching this video, something extraordinary is happening inside your body. Deep within every cell, fragments of DNA are whispering secrets from a vanished world. These aren't your genes. They don't belong to any human alive today. They're ghostly echoes from a species so mysterious that until 15 years ago, we didn't even know they existed. Meet the Denisovans, humanity's most enigmatic cousins, who ruled vast stretches of our planet for hundreds of thousands of years, then disappeared so completely that we found only 4 teeth, a finger bone, and fragments of jaw to prove they ever lived. Yet their DNA flows through millions of people alive today, carrying survival secrets that still save lives 40,000 years after their extinction. This is the ultimate cold case of human evolution, where the victim is an entire species and the evidence lives inside you. Picture the moment everything changed. December 2010, Max Planck Institute for Evolutionary Anthropology, Leipzig, Germany. Dr. Svante Pääbo, the world's leading expert on ancient DNA, stares at his computer screen in disbelief. The genetic sequence displayed before him should be impossible. The sample came from a single finger bone discovered in Denisova Cave, deep in Siberia's Altai Mountains. It should be Neanderthal. It should be modern human. Instead, it's something else entirely. A genetic signature unlike anything in the scientific record. With trembling hands, Pääbo runs the analysis again and again. The results don't change. They've discovered a ghost species, a lost branch of the human family tree that had been hiding in plain sight for 50,000 years. But here's where this story becomes personal, where it stops being ancient history and becomes your history. While we've barely found enough Denisovan bones to fill a small box, their genetic material comprises up to 6% of the genome in modern Papua New Guineans and Aboriginal Australians. They're gone, yet they're everywhere. Their DNA signature stretches across Asia like fingerprints on a crime scene, from the oxygen-starved peaks of the Himalayas to the humid jungles of Southeast Asia, telling the story of a people who didn't just survive in these environments, they dominated them in ways that still leave scientists speechless. The Denisovans weren't just another group of early humans scratching out a living in prehistoric caves. They were evolutionary titans, genetic architects who solved survival challenges that would kill most modern humans within days. They had adaptations so sophisticated that their DNA still functions as biological insurance policies in populations around the world. Tibetans breathing easily at altitudes where most humans would collapse within hours. That's Denisovan genetics at work. Pacific Islanders carrying immune system variants that protect against diseases we've never encountered. Denisovan inheritance passed down through 40,000 years of survival. They engineered biological solutions to planetary challenges, then embedded those solutions so deeply in human DNA that they became immortal. Yet somehow, while their supposedly weaker cousins, the Neanderthals, lasted until 40,000 years ago, and we modern humans conquered the globe, the Denisovans simply vanished. Not gradually, not in a single catastrophic event, but in a way so mysterious that it's taken cutting-edge genetic archaeology to even detect their disappearance. They possessed genetic superpowers that should have made them the ultimate survivors. They thrived in environments ranging from Arctic tundra to tropical islands. They survived ice ages, volcanic catastrophes, and predator pressures that wiped out species with millions of years of evolutionary advantage. They should have inherited the Earth. Instead, they became ghosts in our DNA, their existence revealed only through the most sophisticated genetic detective work in human history. Every major breakthrough in ancient DNA analysis has deepened the mystery rather than solved it. We've discovered they interbred not just with modern humans and Neanderthals, but possibly with even more ancient human species we haven't even identified yet. Their genome contains super-archaic DNA sequences, suggesting they absorbed genetic material from human lineages that diverged from our common ancestors over 1 million years ago. They weren't just survivors, they were genetic collectors, accumulating adaptive advantages from every human species they encountered across hundreds of thousands of years. The more we learn about them, the more impossible their disappearance becomes. They had bigger brains than modern humans in some populations. They developed sophisticated technologies we're still trying to understand. They successfully colonized environments so diverse that no other human species even attempted to survive in all of them. They created art, buried their dead with ritual care, and maintained cultural traditions across distances that would challenge modern communication networks. They were, by every measure that matters, evolution's most successful experiment in human adaptation. Yet they vanished while we inherited their world. The question that will haunt this entire investigation isn't just what happened to the Denisovans, it's why the most perfectly adapted human species in evolutionary history lost the ultimate survival game to cousins who seemed far less equipped for the challenges ahead. The answer, hidden in caves across Asia and written in the genetic code of millions of living people, will challenge everything you think you know about human evolution, survival, and what it really takes to inherit the Earth. But before we can solve the mystery of their disappearance, we need to journey back to a world where 3 different types of humans walk the same planet, each perfectly adapted to their corner of an Earth that looks nothing like the world we know today. A world where survival wasn't guaranteed, where extinction was always one catastrophe away, and where the difference between becoming ancestors and becoming ghosts came down to choices that still echo in our DNA today. 100,000 years ago, Earth hosted not one human species, but 3, each ruling their domain like evolutionary kings in a world so alien it might as well be another planet. This is the stage where our mystery unfolds. A frozen, brutal landscape where ice sheets stretched across entire continents. Sea levels dropped hundreds of feet below modern levels, and massive land bridges connected what are now separate worlds. The air itself was different, thinner, colder, filled with the sounds of creatures that would dwarf any predator alive today. And in this harsh theater of survival, 3 radically different experiments in human evolution were about to collide in ways that would determine the future of intelligence on Earth. In the frozen caves of Europe, Neanderthals had been perfecting the art of Ice Age survival for over 200,000 years. Picture them not as the brutish cavemen of popular imagination, but as living furnaces, their stocky bodies engineered by evolution to generate and conserve heat in conditions that would kill modern humans within hours. Their brains were actually larger than ours, packed with neural architecture that could process complex 3-dimensional hunting strategies and maintain detailed mental maps of territories spanning hundreds of miles. They weren't just surviving Europe's endless winters, they were thriving, crafting tools so sophisticated that modern archaeologists struggle to replicate them, creating art that reveals emotional depths we're only beginning to appreciate, and developing cultural traditions so complex they included burying their dead with flowers and creating the world's first jewelry from eagle talons and seashells. Meanwhile, in Africa's Great Rift Valley, early modern humans were preparing for the greatest migration in planetary history without even knowing it. We were the underdogs in this evolutionary competition, lean and tall where our cousins were robust and powerful, built for endurance rather than strength, with brains wired for social cooperation on scales never before seen in human evolution. We looked fragile compared to our Neanderthal cousins, almost helpless compared to the genetically supercharged Denisovans, but we carried something neither of them possessed, a dangerous gift for turning individual weakness into collective strength. Our ancestors were already developing the social technologies that would eventually reshape entire continents, though they had no idea they were carrying weapons that would prove more devastating than any genetic advantage. And across Asia's vast expanse, from Siberia's permafrost to the steaming jungles of Southeast Asia, the Denisovans had achieved something unprecedented in human evolution. They had become biological shapeshifters, the ultimate adaptive species. Their DNA reveals genetic modifications so sophisticated they seem almost fictional, evolutionary solutions to survival challenges that would stump modern biotechnology. They could thrive at altitudes where the air is too thin for most humans to remain conscious. They could survive Arctic temperatures that would freeze the blood of their European cousins. They could digest foods so diverse that their gut bacteria represented entire ecosystems of metabolic flexibility. They weren't just adapted to multiple environments, they were adapted to environmental change itself, carrying genetic toolkits that could respond to whatever challenges the planet threw at them. The world these three species inhabited was Earth in crisis mode, a planet where survival meant adapting to constant catastrophe. Massive volcanic eruptions periodically darkened skies for years at a time, creating nuclear winter conditions that could last decades. Ice ages advanced and retreated like geological tsunamis, reshaping entire continents within time frames that made adaptation a life-or-death race against environmental chaos. Sea levels rose and fell by hundreds of feet, creating and destroying land bridges that could isolate populations for tens of thousands of years, then suddenly reconnect them in collision courses that would determine evolutionary winners and losers. This was also the age of megafauna, a time when every hunt was potentially lethal, when predators larger than modern elephants stalked landscapes where a single wrong decision could end not just individual lives, but entire bloodlines. Cave bears that stood 12 feet tall on their hind legs. Saber-toothed cats with killing tools evolved over millions of years. Woolly rhinoceros with horns that could split trees. Short-faced bears that could outrun horses and had bite forces that would crush modern grizzlies. These weren't just predators, they were evolutionary arms races made flesh. Creatures so perfectly designed for killing that survival meant developing technologies, strategies, and social structures sophisticated enough to turn prey species into apex predators. But here's where our story takes its first shocking turn. These three human species weren't just sharing this brutal planet. They were about to encounter each other in ways that would trigger the most consequential collision in the history of intelligence on Earth. Climate change was forcing unprecedented migrations. Ice ages were opening new routes while closing others. Ocean levels were shifting, creating temporary passages between worlds that had been separated for hundreds of thousands of years. And somewhere, in the chaos of a planet reshaping itself, our ancestors were about to make contact. The Denisovans had no way of knowing they were living through their final evolutionary act. They had survived multiple ice ages, volcanic catastrophes that wiped out countless other species, and predator pressures that would terrify modern humans. They had developed technologies we're still trying to understand and genetic adaptations that seem almost superhuman in their sophistication. They controlled territories spanning from Arctic Siberia to tropical Southeast Asia, making them the most geographically successful human species in evolutionary history. By every measure that should matter in the survival game, genetic fitness, environmental adaptation, technological sophistication, territorial control, they should have been the obvious winners in any competition for Earth's future. Yet within the next 50,000 years, two of these three species would vanish forever, leaving only genetic echoes in our DNA and scattered bones in caves as evidence they ever existed. The question that drives this entire investigation: why did the most adapted species lose the ultimate survival game? Begins with a revelation that will fundamentally change how you understand human superiority. Because the Denisovans possessed genetic advantages so sophisticated they make modern human achievements look primitive by comparison, and understanding exactly what those advantages were will make their disappearance even more shocking. The Denisovan genome reads like science fiction written by evolution itself, a biological instruction manual for surviving challenges that would kill modern humans within days. These weren't just another group of prehistoric people struggling to survive. They were nature's most ambitious experiment in human enhancement, carrying genetic modifications so sophisticated that 40,000 years later, we're still trying to understand how they worked. Their DNA doesn't just tell the story of survival. It tells the story of biological mastery on a planetary scale. Adaptations so remarkable they saved lives in populations that never even knew the Denisovans existed. Let's start with something that will literally take your breath away. Right now, on the roof of the world, Tibetan families are living comfortable lives at altitudes where most humans would lose consciousness within hours. They're herding yaks at 16,000 feet above sea level, where the oxygen concentration is so low that mountain climbers require weeks of acclimatization and sophisticated equipment just to survive temporarily. Children are running and playing in conditions that would send lowland humans into life-threatening oxygen deprivation. How is this possible? The answer lies in their DNA, where Denisovan genes inherited from ancestors they'll never know about are performing biological miracles that seem to defy human physiology. The EPS1 gene passed down directly from Denisovan populations doesn't just help with altitude adaptation, it completely rewires oxygen metabolism in ways that modern medicine is still trying to replicate. Where most humans respond to low oxygen by producing more red blood cells, creating a dangerous thickening of the blood that can cause strokes and heart attacks. Tibetans with Denisovan variants maintain optimal blood viscosity while extracting oxygen from thin air with efficiency that challenges our understanding of human biological limits. This isn't just genetic adaptation, this is evolutionary engineering that took hundreds of thousands of years to perfect, embedded so deeply in their DNA that it functions like biological nanotechnology. But altitude mastery was just the beginning of the Denisovan genetic toolkit. Their genome reveals immune system variants so sophisticated they suggest these people routinely survive disease pressures that would have caused demographic collapse in any other human population. They carried resistance genes for viral families we've never encountered, bacterial infections that existed in environments we've never explored, and parasitic challenges that would overwhelm modern medical responses. Their immune systems weren't just adapted to their specific disease environment, they were adapted to disease itself, carrying genetic architectures that could respond to pathogenic challenges with flexibility that made them nearly indestructible from a microbial warfare perspective. Archaeological evidence from their teeth tells an even more incredible story of biological adaptation. Denisovan molars were massive, complex grinding machines that revealed dietary capabilities spanning from Arctic marine mammals to tropical fruits and everything in between. They weren't just omnivores, they were dietary shapeshifters, capable of extracting nutrition from food sources so diverse it challenges modern nutritional science. Their gut bacteria, reconstructed from genetic analysis, represented entire ecosystems of metabolic flexibility, allowing them to digest foods that would be toxic to other human populations and extract calories from resources that would be considered inedible by modern standards. The sensory adaptations revealed in their DNA suggest they were living in a perceptual world we can barely imagine. Enhanced cold resistance genes allowed them to maintain fine motor control and cognitive function in temperatures that would cause hypothermia in modern humans. Heat shock protein variants suggest they could also survive tropical conditions that would cause heat stroke in populations adapted to temperate climates. They weren't just surviving in multiple environments, they were thriving in environmental ranges that spanned the entire habitable spectrum of the planet. But perhaps the most remarkable discovery in the Denisovan genome is evidence of genetic time travel. Their DNA contains super archaic sequences that suggest they successfully interbred with human species so ancient we haven't even discovered them yet. Populations that diverged from our common ancestors over 1 million years ago. They weren't just adapting to their contemporary environment, they were collecting genetic solutions from across the entire span of human evolutionary history. accumulating adaptive advantages like biological treasure hunters, gathering survival tools from every human lineage they encountered. Modern genetic analysis reveals they achieved successful reproduction in environments ranging from Siberian permafrost, where winter temperatures regularly dropped to 40 degrees below zero, to tropical Southeast Asian islands where humidity and disease pressure would challenge any modern expedition. This isn't just environmental flexibility. This is biological mastery of planetary diversity on a scale no other human species even attempted. They were living proof that human adaptation could overcome any environmental challenge Earth could present. The most haunting aspect of their genetic legacy is how valuable their adaptations proved to the human populations that inherited them. Denisovan altitude genes now allow millions of people to live comfortably in high-altitude environments. Their immune variants provide disease resistance that saves lives in modern population. Their metabolic adaptations help Arctic peoples survive extreme cold and tropical populations manage heat stress. We didn't just inherit random genetic material from them. We inherited evolutionary solutions to problems we didn't even know we'd face. They were biological prophets, developing genetic technologies for challenges that wouldn't become apparent until tens of thousands of years after their extinction. Yet, here's the paradox that makes their disappearance so mystifying. All of these genetic superpowers, all of this biological mastery, all of these evolutionary advantages that seem almost superhuman in their sophistication should have made them absolutely indestructible as a species. They had genetic insurance policies for every environmental challenge, biological solutions for every survival problem, adaptive capabilities that made them the ultimate evolutionary success story. So why are we about to witness the rise of a species that seemed catastrophically unprepared for the challenges that lay ahead? Everything we've been taught about evolutionary success is wrong, and the proof is standing in front of the mirror looking back at you. While Denisovans were engineering genetic perfection and Neanderthals were building physical supremacy, modern humans were developing something that seemed like evolutionary suicide but proved to be the most devastating weapon in the history of life on Earth. We were weak, catastrophically obviously, almost comically weak. And that weakness forced us to invent something our genetically superior cousins never needed: the ability to turn individual helplessness into collective invincibility. Picture early modern humans 60,000 years ago, and you're looking at evolution's biggest losers in almost every category that should matter for survival. Our bodies were fragile sticks compared to the robust fortress builds of Neanderthals. We lacked the Denisovans' genetic superpowers for environmental adaptation. We couldn't survive extreme cold without technology, couldn't fight megafauna with bare hands, couldn't even regulate our body temperature effectively without tools and shelter. We were the evolutionary equivalent of premature babies trying to survive in a world designed for giants. By every physical and genetic measure, we were the least qualified species to inherit anything, let alone the entire planet. But weakness, it turns out, can be the greatest evolutionary advantage if it forces the right kind of innovation. While a Neanderthal family of 4 or 5 could survive independently using their superior physical capabilities, and a Denisovan group could adapt to almost any environment using their genetic flexibility, we required something unprecedented in human evolutionary history just to make it through a single winter: massive social networks functioning as collective survival machines. Our weakness didn't make us inferior, it made us desperate enough to become something entirely new. Archaeological sites reveal the revolutionary scale of early modern human cooperation. Where Neanderthal sites rarely show evidence of groups larger than 20 or 30 individuals, our ancestors were creating communities of 50, 100, sometimes 150 people working together with coordination that still astounds anthropologists. We weren't just living in larger groups. We were living as superorganisms, where individual survival became secondary to collective survival, where personal genetic fitness mattered less than group genetic success. Our camps became biological factories for manufacturing survival advantages that no individual human could achieve alone. This social revolution unlocked capabilities that transcended anything genetic adaptation could provide. While Denisovans had superior altitude genes, we could create technologies and strategies that allowed us to conquer any altitude. While Neanderthals had stronger bodies for hunting large game, we could organize hunting parties that brought down prey no individual could tackle, using coordination strategies that turned human weakness into predatory supremacy. We didn't adapt to our environment, we forced our environment to adapt to us, but the real weapon was information warfare. We became the first species in Earth's history to develop culture as a primary survival strategy, where knowledge didn't die with individuals but accumulated, improved, and spread through our expanding social networks like a biological internet. A tool innovation discovered by a group in Africa could eventually save lives in Europe. A hunting strategy developed in Asia could reach populations that had never seen the prey it was designed for. We weren't just surviving generation by generation, as we were building cumulative advantage that compounded over time like evolutionary compound interest. The archaeological evidence reveals this information revolution in stunning detail. While our cousins were making the same types of tools their ancestors had made for hundreds of thousands of years, we were innovating so rapidly that our technology evolved visibly within single human lifetimes. We weren't just making we were making tools to make tools, developing technologies to develop technologies, creating recursive improvement cycles that generated adaptive capabilities faster than biological evolution could match. Our weakness had forced us to become the first, truly technological species. This technological acceleration was only possible because of our social architecture. Individual Neanderthals might be smarter than individual modern humans, and individual Denisovans might have superior genetic capabilities, but our groups were collectively more intelligent than any individual from any species. We had accidentally invented something that wouldn't be formally recognized by science for another 60,000 years: distributed cognition, where the thinking power of entire communities could be brought to bear on survival challenges. The timing of our explosive expansion out of Africa reveals the devastating effectiveness of our social weapon. Just as climate change was intensifying, creating exactly the conditions where superior genetic adaptations should provide decisive advantages, we began colonizing environments where we had no business surviving. We weren't spreading because we were better adapted to new environments. We were spreading because we could rapidly develop cultural adaptations that functioned better than genetic ones, creating survival solutions in decades that would take genetic evolution millennia to achieve. Our social cooperation enabled exponential problem-solving capabilities that our cousins couldn't match. When Denisovan groups encountered new environments, they relied on genetic capabilities developed over hundreds of thousands of years. When Neanderthal groups faced new challenges, they applied individual intelligence and physical capabilities refined by millennia of natural selection. When we encountered problems, we applied the collective intelligence of entire communities, sharing solutions across social networks that spanned continents. We had become a single, planet-spanning problem-solving organism disguised as scattered tribes of physically inferior humans. But as our social weapon grew more powerful, something was happening to the Denisovans that their genetic superpowers couldn't defend against. They were about to face an enemy that would render all their biological advantages useless, an enemy so small it was invisible, yet so devastating it would ultimately seal their evolutionary fate. The greatest immune systems in human evolutionary history were about to encounter their first truly unwinnable war. The Denisovans had built the most sophisticated immune system in human evolutionary history, a biological fortress so advanced it could repel diseases that would cause demographic collapse in any other human population. Their genetic architecture contained resistance mechanisms for viral families we've never encountered, bacterial threats that thrived in environments we've never explored, and parasitic challenges that would overwhelm modern medical responses. They had survived plagues that wiped out entire ecosystems, developing immunity to pathogenic threats that had been testing human survival for hundreds of thousands of years. They were the ultimate biological survivors, carrying immune technologies that made them nearly indestructible from a disease warfare perspective. Yet, they were about to encounter an enemy their genetic perfection couldn't recognize, couldn't fight, and couldn't survive. An invisible weapon traveling in the bloodstream of every modern human who wandered into their territory. Disease has shaped human evolution more profoundly than wars, climate change, or any predator that ever stalked our ancestors. But the Denisovans seem to have cracked the pathogenic code entirely. Genetic analysis reveals immune system variants so sophisticated they suggest these populations routinely survive disease pressures that would have caused extinction events in other human species. They carried viral resistance genes that scientists are still studying today, including adaptations to pathogens we've never even encountered. Their white blood cell production capabilities, T-cell response mechanisms, and antibody generation systems were like biological weapons laboratories, hardened by millennia of surviving in environments where disease pressure was constant, merciless, and absolutely lethal to any population lacking their genetic advantages. But evolutionary perfection in one arena can become evolutionary suicide when the rules of the game suddenly change. The Denisovans' incredible immune adaptations were laser-focused on their specific environments, their familiar pathogens, their well-known evolutionary challenges. They were prepared for everything their world had thrown at them across hundreds of thousands of years of genetic refinement. Everything except what was coming from outside their world entirely. They had built immune systems designed to fight the diseases of Asia, not the diseases of Africa. And modern humans, expanding out of our ancestral continent, were walking biological warfare laboratories carrying pathogenic arsenals the Denisovan immune system had never encountered. Picture that first contact somewhere in Central Asia, perhaps along what would eventually become the Silk Road, where a Denisovan hunting party encounters something unprecedented in their evolutionary experience. Modern humans, carrying within their bodies microscopic weapons no genetic superpower could anticipate. We weren't intentionally bringing biological warfare to their territories. We were simply carrying the diseases of our African homeland, pathogens. Our immune systems had been fighting for hundreds of thousands of years, microorganisms that had shaped our genetic development since before our species even existed. To us, these were manageable health challenges. To populations that had never encountered them, they were extinction-level events waiting to happen. The human diaspora out of Africa wasn't just a migration. It was inadvertent biological colonialism on a planetary scale. Every population we contacted faced the same devastating pattern. First encounter, then disease transmission, then demographic catastrophe. This wasn't malicious biological warfare. It was the simple, brutal reality that isolated populations have no immunity to foreign pathogens, especially pathogens that had been co-evolving with different human populations for hundreds of thousands of years. We were inadvertently carrying biological weapons that could cause population crashes in any group that hadn't been exposed to African disease environments. The Denisovan tragedy was that their genetic advantages actually made them more vulnerable, not less. Their immune systems were so precisely calibrated to their specific disease environments that encountering African pathogens was like sophisticated computer networks being attacked by viruses they had no programming to recognize. Their white blood cells, trained by millennia of fighting Asian diseases, couldn't identify threats they had never encountered. Their antibody production systems, perfected for familiar pathogens, couldn't generate responses to microbial invaders that operated by completely different biological rules. Archaeological evidence suggests the collapse wasn't immediate, but cascading, like dominoes falling across an entire continent. Denisovan sites that showed continuous occupation for tens of thousands of years began displaying signs of demographic stress around 50,000 years ago, exactly coinciding with the first evidence of modern human expansion across Asia. Communities that once supported hundreds of individuals suddenly showed evidence of much smaller groups. Tool technologies that had been sophisticated and varied became simpler and more standardized, suggesting populations under severe survival stress were losing the specialized knowledge that thriving communities could maintain. The genetic evidence tells an even more heartbreaking story of demographic collapse accelerated by disease pressure. DNA analysis reveals that as Denisovan populations crashed, the survivors increasingly sought genetic rescue through interbreeding with modern humans. Not occasionally, as romantic encounters between different human species, but systematically and desperately, as communities facing extinction attempted to maintain viable breeding populations through any means available. Their genetic material was being absorbed into our lineage not through cultural exchange or peaceful coexistence, but through the mathematical desperation of populations too small to survive independently. Modern populations in Papua New Guinea and Aboriginal Australia carry high percentages of Denisovan DNA, not because their ancestors were particularly attracted to Denisovan partners, but because these regions represented refugia, the last places where Denisovan populations survived long enough to interbreed extensively with modern human migrants before their own demographic collapse became irreversible. These genetic signatures represent the final chapters of the Denisovan story, where survival meant genetic absorption rather than independent cultural existence. The cruelest irony is that many Denisovan genetic variants proved incredibly advantageous to modern human populations who inherited them. Their immune system innovations provided disease resistance that saves lives today. Their metabolic adaptations helped human populations survive in environmental extremes. Their sensory and physiological enhancements improved human survival capabilities in ways we're still discovering. But by the time we recognize the value of their genetic innovations, the communities that had developed them over hundreds of thousands of years were already extinct, existing only as molecular echoes in the DNA of populations that had inadvertently destroyed them. Yet disease was only the opening act in the Denisovan extinction story. While pathogens were weakening their populations and forcing them into smaller, more vulnerable groups, modern humans were about to unleash something even more devastating than biological warfare, something that would transform entire continents and make the environments the Denisovans had mastered for millennia completely uninhabitable for their specialized survival strategies. Modern humans didn't just carry diseases across continents. We carried something far more devastating and permanent: the ability to consciously reshape entire ecosystems, transforming landscapes that had sustained Denisovan populations for hundreds of thousands of years into alien environments where their genetic superpowers became evolutionary liabilities overnight. This wasn't gradual environmental change that populations could adapt to over millennia. This was ecological warfare conducted at the speed of human innovation, turning stable environments into chaotic landscapes where survival required completely different strategies than the ones Denisovan genetics had been perfecting for 500,000 years. The evidence of our ecological impact is written in pollen cores, extinction layers, and sediment deposits across every continent we colonized. Wherever modern humans established permanent settlements, the environmental signature changes dramatically within just a few thousand years, sometimes within centuries. Lakes that had maintained stable ecosystem patterns for tens of thousands of years suddenly show radical shifts in plant species, animal populations, and even basic soil chemistry. This wasn't natural climate change or gradual environmental evolution. This was ecosystem engineering conducted by a species that had learned to manipulate natural systems as survival tools, transforming entire landscapes to serve human needs rather than adapting human behavior to serve landscape requirements. Picture the Denisovan world before our arrival: vast grasslands supporting megafauna herds that had grazed the same migration routes for millennia, stable forest systems where the same hunting strategies had worked for hundreds of thousands of years, predictable seasonal cycles where water sources, food availability, and shelter locations followed patterns so reliable that genetic adaptations could be calibrated to exploit them with extraordinary precision. The Denisovans weren't just adapted to these environments, they were evolutionary products of these specific ecological relationships, their entire biological and cultural existence, dependent on environmental stability that had persisted since before modern humans even existed as a separate species. But we brought something revolutionary and terrifying: the systematic use of fire as an ecological weapon. While other human species used fire for cooking and warmth, we discovered that fire could be used as a landscape-scale tool for reshaping entire ecosystems to better serve our survival needs. We burned forests to create grasslands that would concentrate game animals in predictable hunting areas. We burned grasslands to eliminate cover for predators and competitors. We burned entire watersheds to force changes in animal migration patterns, water flow, and plant community composition. We weren't just living within existing ecosystems, we were actively redesigning them according to human specifications. The Australian example reveals the devastating scale and speed of this ecological warfare. When modern humans reached Australia around 50,000 years ago, the continent supported ecosystems that had been stable for millions of years, including Denisovan descendant populations that had been successfully hunting Australian megafauna for potentially 100,000 years. Within 10,000 years of modern human arrival, an evolutionary eye blink, over 90% of Australia's large-bodied animal species went extinct. The entire continental ecosystem transformed from one dominated by massive herbivores and their specialized predators to the modern Australian landscape of smaller, more generalized species. This wasn't gradual extinction caused by climate change, this was rapid ecosystem collapse caused by human firestick farming and systematic megafauna. Hunting, the Denisovan tragedy, was that their genetic advantages became evolutionary traps when the environments they were adapted to disappeared. Their sophisticated altitude adaptations were useless if we burned the high elevation forests they depended on for shelter and resources. Their diverse dietary capabilities meant nothing if we drove the megafauna they specialized in, hunting, into extinction. Their cold-weather genetic modifications couldn't help them if we eliminated the plant communities that provided their traditional winter foods. Their disease resistance was irrelevant if ecological disruption destroyed the resource bases their communities needed to maintain viable population sizes. Archaeological evidence shows this pattern repeating across Asia with ruthless consistency. Denisovan sites that demonstrated continuous occupation for tens of thousands of years suddenly display signs of resource stress, population decline, and eventual abandonment within just a few millennia of the first modern human presence in their regions. We weren't just outcompeting them for existing resources, we were systematically eliminating the resources their entire evolutionary strategy depended on, forcing them into increasingly marginal environments where their specialized adaptations provided diminishing survival advantages. The timing reveals the calculated efficiency of this ecological assault. Climate change was already forcing Denisovan populations into refugia, where they were most concentrated and therefore most vulnerable to systematic environmental manipulation. When modern humans arrived with fire-based ecosystem management, coordinated megafauna hunting strategies, and rapid habitat modification techniques, we targeted exactly the environments where Denisovan survivors were trying to maintain their traditional lifestyles. We were unknowingly conducting ecological genocide against populations whose survival strategies required environmental stability we were systematically destroying. Modern isotope analysis of Denisovan remains from their final millennia shows their diets becoming increasingly restricted and nutritionally inadequate, suggesting populations that had once enjoyed dietary diversity, spanning from marine resources to high-altitude plant foods, were being forced into narrower and narrower ecological niches. They were literally starving in landscapes their ancestors had thrived in for hundreds of thousands of years, not because the landscapes were naturally changing, but because human ecological modification was making their traditional survival strategies impossible to maintain. Cave sites where Denisovan and modern human occupations overlap provide the most haunting evidence of this ecological replacement happening in real time. These archaeological layers show Denisovan cultural materials becoming progressively simpler and less diverse, indicating populations under increasing survival stress, while modern human layers show expanding populations with increasingly sophisticated technologies specifically designed for environmental manipulation. It wasn't conquest through direct competition, it was ecological replacement where entire human populations were being starved out of existence by environmental changes they couldn't adapt to quickly enough. But the final blow to the Denisovans wasn't disease pressure or ecological destruction. It was something that would haunt human evolution forever after. The mathematics of genetic absorption, where survival became possible only by surrendering the very identity that had made survival possible in the first place. The end of the Denisovans wasn't a dramatic extinction event that paleontologists could point to in rock layers or archaeological sites. It was something far more insidious and heartbreaking, a slow genetic dissolution where survival meant disappearing into the DNA of their conquerors, losing their cultural identity, one intermarriage at a time until nothing remained but molecular fragments in the bloodstreams of populations that would never know their names. This was extinction by absorption, where the final choice facing the last. Denisovan communities wasn't between death and survival. It was between death and becoming something else entirely. Population genetics reveals a mathematical nightmare that no amount of genetic superiority could solve. When human populations fall below certain critical thresholds, usually somewhere between 50 and 500 breeding individuals, depending on environmental conditions, survival becomes biologically impossible without genetic input from outside populations. Inbreeding depression becomes inevitable, genetic defects multiply, fertility rates plummet, infant mortality soars, and immune systems become compromised by lack of genetic diversity. The Denisovans, despite carrying the most sophisticated adaptive genetics in human evolutionary history, had reached this demographic death spiral across most of their range. Picture the final Denisovan communities scattered across Asia around 30,000 years ago, isolated groups of 20, 30, maybe 50 individuals huddled in caves from Siberia to Southeast Asia. Their numbers too small to sustain healthy breeding populations, but too proud of their ancient heritage to simply surrender to extinction. These weren't random survivors. These were the last repositories of genetic knowledge that had taken 500,000 years to accumulate, carrying in their DNA the evolutionary solutions to survival challenges that modern science still struggles to understand. Yet they faced an impossible choice: maintain their genetic purity and watch their children suffer from the biological consequences of inbreeding, or seek genetic rescue from the very populations whose expansion was driving them toward extinction. They chose survival, and modern DNA analysis reveals how systematic and desperate that choice became. Denisovan genetic introgression into modern human populations wasn't occasional or romantic. It was extensive, coordinated, and conducted with the mathematical precision of populations consciously choosing genetic absorption as their only path to biological continuity, surviving. Denisovan women were having children with modern human men at rates that could only occur if Denisovan communities were actively, deliberately seeking genetic rescue from outside populations, trading their cultural independence for their children's biological viability. The genetic evidence tells a story that would break your heart if you could see it happening in real time. As Denisovan populations crashed below sustainable levels, intermarriage with modern humans became not just common, but essential for producing healthy offspring. Each generation saw Denisovan genetic percentages diluting further. Denisovan cultural knowledge being lost as children grew up in increasingly mixed communities, and Denisovan languages disappearing as fewer and fewer people remained who could speak them fluently. Entire libraries of ecological knowledge, technological innovations, and spiritual traditions that had been passed down for hundreds of thousands of years vanished forever, leaving only DNA fragments as evidence they had ever existed. This genetic salvation came at the ultimate cultural cost, the complete erasure of Denisovan identity as a distinct human experience. Technologies that had allowed them to thrive in environments no other human species could survive were forgotten when the last master craftspeople had no apprentices to teach. Oral histories that preserved 500,000 years of human experience died with the last fluent storytellers. Social structures, religious beliefs, and artistic traditions that represented unique experiments in human consciousness disappeared as thoroughly as if they had never existed, leaving only genetic echoes in populations that would never understand what they had inherited. The process wasn't uniform across their range, and the variations reveal the desperation of their final centuries. In Southeast Asia and Melanesia, where geographic isolation provided more time for gradual demographic mixing, higher percentages of Denisovan DNA survived in modern populations, up to 6% in some Papua New Guinean groups, suggesting their ancestors were essentially hybrid communities where Denisovan and modern human contributions were nearly equal. But in Central Asia and Siberia, where modern human population pressure was more intense and environmental disruption more severe, Denisovan genetic signatures are barely detectable, suggesting populations that were overwhelmed. So rapidly they had little opportunity for gradual integration. The cruelest irony is that many Denisovan genetic variants proved incredibly valuable to the modern human populations that absorbed them. Their altitude adaptations now allow millions of Tibetans to live comfortably at elevations that would incapacitate lowland peoples. Their immune system innovations provide disease resistance that saves lives in populations around the world. Their metabolic flexibility helps Arctic and tropical populations survive in environmental extremes that would challenge any other human genetics. We didn't just inherit random genetic material from them. We inherited their evolutionary solutions to problems we didn't even know we would face, making us more adaptable, more resilient, and more capable of surviving in diverse environments than we ever could have been alone. Modern genetic techniques can even estimate when different Denisovan populations finally disappeared as distinct communities. The most recent Denisovan DNA introgression in modern human genomes dates to around 15,000 years ago in some Asian populations, suggesting isolated Denisovan communities survived much longer than previously thought, possibly long enough that some traditional societies might preserve oral memories of these final encounters in their cultural narratives, though we would never recognize them as historical rather than mythological accounts. Yet even as the Denisovans were dissolving into genetic memory, their cousins, the Neanderthals, were demonstrating why some human species endure longer than others, and why their survival strategy would ultimately doom them to the same fate, revealing the single most important factor that determines which human lineages inherit the future and which become evolutionary footnotes. The Neanderthals should have vanished with the Denisovans. They faced identical diseases, identical ecological warfare, identical demographic pressures from expanding modern human populations, yet they survived 10,000 years longer, maintaining their cultural identity and territorial control until as recently as 28,000 years ago, long enough to leave extensive archaeological records of their final struggles. Their extended survival reveals exactly why some human species endure while others vanish, but their ultimate fate demonstrates why the factors that enable short-term survival can become long-term evolutionary death traps. Neanderthals made what seemed like a brilliant evolutionary bet. Extreme specialization for specific environmental conditions rather than the generalist approach of modern humans or the environmental shape-shifting strategy of the Denisovans. While their cousins were spreading across multiple environments or developing complex social networks, Neanderthals doubled down on becoming the ultimate European Ice Age humans. Their bodies were biological masterpieces of cold weather engineering, compact, heavily muscled, with metabolic rates calibrated for extracting maximum energy from high-fat diets and maintaining core body temperature in conditions that would kill modern humans. Their brains were actually larger than ours on average, packed with neural architecture specifically optimized for processing complex three-dimensional spatial information and maintaining detailed mental maps of hunting territories. This specialization strategy provided crucial advantages that the more generalized Denisovans couldn't match when modern human expansion began. Neanderthals weren't trying to occupy every ecological niche or adapt to every possible environment. They had carved out specific territories where their advantages were so overwhelming that modern human competition was severely limited. In the frozen forests of Ice Age Europe, with their superior cold adaptations, specialized hunting technologies, and intimate knowledge of local conditions accumulated over 200,000 years, they could not just hold their ground, but actually thrive alongside modern human populations. Archaeological evidence shows Neanderthals weren't just surviving initial contact with modern humans, they were demonstrating remarkable resilience and adaptation to competitive pressure. Sites across Europe reveal Neanderthal populations adopting modern human technologies when they proved useful, developing new tool-making techniques in response to changing conditions, and even expanding into new territories as Ice Age conditions shifted. They weren't passive victims of modern human expansion, they were active competitors responding to demographic and technological challenges with innovations that allowed them to maintain their traditional lifestyles for thousands of years after initial contact. Some Neanderthal populations showed such successful adaptation to modern human presence that they actually increased their territorial ranges and developed more sophisticated technologies during the early phases of coexistence. Sites like Gorham's Cave in Gibraltar demonstrate Neanderthal communities maintaining complex cultural traditions, creating sophisticated art, and even developing new hunting strategies until as recently as 28,000 years ago, over 20,000 years after modern humans first entered Europe. They were proving that specialized human species could compete successfully with generalist species under the right environmental conditions, but their survival strategy contained the seeds of their ultimate destruction. The same specialization that made them dominant in Ice Age Europe became a demographic death trap when climate change began transforming their specialized environments 30,000 years ago. As glaciers retreated, forests expanded, and the megafauna they specialized in hunting disappeared or migrated to different regions. The environmental conditions that had favored Neanderthal genetic and cultural adaptations began vanishing faster than biological evolution could compensate. Modern humans, with our social flexibility and cultural adaptation capabilities, could adjust to changing environments within single generations by developing new technologies, modifying social structures, and sharing innovations across our expanding networks. Neanderthals, locked into genetic specializations refined over hundreds of thousands of years, and cultural traditions optimized for specific environmental conditions, couldn't adapt quickly enough to environmental changes that were occurring within decades rather than millennia. Their evolutionary advantages became evolutionary anchors, holding them to environmental conditions that were disappearing. The final Neanderthal populations reveal this tragic transformation in heartbreaking detail. Genetic analysis shows increasing signs of inbreeding depression as populations became isolated in shrinking environmental refugia. Their tool technologies actually became simpler over time rather than more sophisticated, suggesting cultural knowledge was being lost as populations crashed and specialized craftsmen died without apprentices to inherit their skills. They were literally forgetting how to be Neanderthal as their demographic base became too small to maintain their traditional cultural complexity. The key difference that allowed Neanderthals to survive longer than Denisovans was precisely what ultimately made them more vulnerable to environmental change. Their more limited geographic range and specialized environmental niche meant they weren't competing with modern humans everywhere, just in specific habitats where their advantages were clear. This reduced direct competition pressure and allowed longer coexistence. But this same territorial limitation made them catastrophically vulnerable when their specialized environments disappeared, leaving them with nowhere to retreat and no alternative survival strategies. Modern genetic analysis reveals that all non-African human populations carry 1 to 4% Neanderthal DNA, compared to much lower and more geographically restricted Denisovan percentages. This suggests Neanderthal-modern human interaction was more extensive, lasted longer, and involved more balanced demographic exchanges than the desperate absorption that characterized final Denisovan survival. Yet the outcome was ultimately identical: genetic integration as the only alternative to complete extinction. The Neanderthal endgame demonstrates why specialization, despite its short-term advantages in stable environments, becomes an evolutionary liability in periods of rapid change. Their investments in Ice Age European conditions became evolutionary debts when those conditions disappeared, proving that even the most sophisticated biological adaptations can become survival handicaps when environmental change outpaces adaptive capacity. But this raises the ultimate question about human survival. If specialized Neanderthals and genetically supercharged Denisovans both failed when confronted with rapid change, why did modern humans, the most generalized, least physically impressive, most environmentally dependent human species, succeed where their superior cousins failed? The answer reveals humanity's most dangerous evolutionary gamble. Here's the most shocking revelation in the story of human evolution. Modern humans, the species that ultimately conquered every environment on Earth, came closer to complete extinction than either the Neanderthals or the Denisovans. Our victory wasn't inevitable, wasn't based on superior adaptations, and certainly wasn't achieved through biological advantages. It was accidental, fragile, and accomplished through survival strategies so risky they should have destroyed us long before we ever encountered our supposedly inferior cousins. We survived not because we were the fittest, but because we were willing to gamble everything on strategies that bordered on evolutionary suicide. Genetic analysis of modern human populations reveals demographic crashes so severe they make Neanderthal and Denisovan population bottlenecks look stable by comparison. The effective breeding population that gave rise to all non-African humans may have collapsed to as low as 1,000 individuals around 70,000 years ago, with a demographic catastrophe that should have ended our species before we ever left our ancestral continent. We experienced multiple near extinctions during our expansion out of Africa, population crashes during the colonization of Asia, demographic disasters during the settlement of Australia, and survival crises so severe that entire continental populations were founded by groups small enough to fit in a modern university lecture hall. Yet these near-extinction events taught us something neither Neanderthals nor Denisovans ever learned: how to survive as a network rather than as discrete populations. When modern human communities face demographic collapse, instead of relying on genetic adaptations like the Denisovans or environmental specialization like the Neanderthals, we developed something unprecedented in human evolutionary history: continent-spanning communication and mutual support. Systems that allowed widely separated populations to function as a single survival organism. Archaeological evidence shows modern human populations maintaining cultural and technological connections across thousands of miles of hostile territory. Tool technologies, artistic styles, genetic markers, and even linguistic elements reveal trade networks and information exchange systems operating on scales that dwarf anything seen in Neanderthal or Denisovan populations. We weren't just surviving locally, but we were surviving as a species, where the success or failure of individual populations became secondary to the success or failure of the entire human network. This network effect provided a crucial advantage in the final competition for planetary dominance. When climate change, disease pressure, or resource depletion overwhelmed local modern human populations, survivors could receive technological support, cultural knowledge, and even genetic rescue from populations thousands of miles away. We had unconsciously created the first global insurance policy, where local extinction didn't mean species extinction because survival, knowledge, and genetic diversity were distributed across continental networks rather than concentrated in isolated communities. But our most dangerous evolutionary gamble was demographic. Instead of maintaining populations at sustainable levels like our cousins, we bet everything on exponential reproductive growth that consistently pushed us beyond the carrying capacity of our immediate environments. Modern human populations expanded so rapidly that we routinely outbred our mortality rates, even when facing catastrophic losses from disease, predation, or environmental disasters. We survived through sheer reproductive momentum, replacing losses so quickly that temporary population crashes couldn't drive us to extinction before recovery. This strategy was incredibly risky and nearly failed multiple times. Exponential population growth meant we consistently exceeded the resource capacity of our environments, forcing constant expansion into new territories where we had no previous survival experience and no specialized adaptations. We couldn't establish stable ecological relationships like the Denisovans or occupy specialized niches like the Neanderthals. We had to keep moving, keep growing, keep innovating, or face demographic collapse when our population size exceeded resource availability. Modern genetic analysis reveals bottlenecks indicating severe population crashes during our expansion across Asia, demographic disasters during the colonization of Australia, and survival crises during the settlement of the Americas. Each time we survived not because we were better adapted to new environments, but because our network connections and reproductive strategies allowed us to recover from losses that would have finished more stable, more sustainable populations. We were the invasive species that succeeded through demographic chaos rather than environmental fitness. Our final advantage was our willingness to gamble on completely untested technological and social innovations rather than relying on proven biological or cultural strategies. While Neanderthals refined existing technologies and Denisovans relied on genetic adaptations, we consistently developed radical new approaches to survival challenges: agriculture, animal domestication, metallurgy, writing systems, complex social hierarchies, not because these innovations were obviously superior, but because our unstable population dynamics required constant adaptation to survive in environments where we didn't belong. The tragic irony is that the same survival strategies that made us the dominant species also made us the most environmentally destructive. Our network approach to survival meant we could coordinate resource exploitation on continental scales, extracting materials from entire ecosystems to support populations in completely different regions. Our demographic gambling meant we consistently overpopulated local environments, forcing expansion that transformed entire landscapes to accommodate human population growth. Our innovation obsession meant we developed technologies that could reshape planetary ecosystems faster than natural selection could adapt other species to human-modified environments. We didn't outcompete the Neanderthals and Denisovans through superior biological fitness. We overwhelmed them through superior demographic instability and technological chaos that native species couldn't match. We were the evolutionary equivalent of an invasive species that succeeds not through adaptation, but through reproductive and cultural disruption that established species cannot respond to quickly enough. Our victory was achieved through strategies so environmentally unsustainable that we're still dealing with their consequences 40,000 years later. And now, as we stand at the threshold of the next phase of human evolution, We're about to discover that the Denisovans' disappearance holds the key to understanding not just our past, but our future. And the choice we'll soon face between extinction and transformation. The story of Denisovan disappearance isn't really about extinction at all. It's about the most radical survival strategy in the history of life on Earth, and it holds the key to understanding not just human evolution, but the future of intelligence itself. In laboratories around the world, scientists are making discoveries that will fundamentally change how you understand what it means for a species to survive, what it means to be human, and what it means to inherit the future. The Denisovans didn't vanish. They pioneered a form of biological immortality that we're only now beginning to recognize, and their strategy may be the only thing that allows intelligence to survive the challenges ahead. Every year brings revelations that make the Denisovans' story more extraordinary and more relevant to our current moment in history. Their DNA doesn't just contain genetic solutions to problems they faced, it contains solutions to problems we're facing now and problems we haven't even encountered yet. As climate change pushes human populations toward high-altitude environments, Denisovan genes are allowing Tibetan populations to thrive in conditions that would incapacitate most humans. As new diseases emerge from environmental disruption, Denisovan immune variants are providing resistance to pathogens that didn't exist when their original carriers died out 40,000 years ago. As our diets become increasingly artificial and our environments become more extreme, Denisovan metabolic adaptations are helping modern populations survive conditions their genes solved hundreds of thousands of years before those conditions existed. Standing in a modern genetics laboratory where researchers are sequencing ancient DNA, you're witnessing something unprecedented in planetary history, an extinct species being resurrected one gene at a time, not in body but in function, not as individuals but as biological solutions embedded so deeply in living populations that they've become unkillable. The Denisovans made the ultimate evolutionary gamble. They traded species survival for genetic immortality, embedding their adaptations so thoroughly in human DNA that they would survive as long as humans survive, regardless of what happens to human culture, human civilization, or even human bodies. This discovery is revolutionizing how scientists understand extinction, evolution, and survival itself. We're realizing that species survival might be a primitive concept compared to genetic survival, that the most successful evolutionary strategy might not be maintaining separate populations indefinitely, but rather integrating adaptive advantages into other successful lineages before demographic collapse makes independent survival impossible. The Denisovans may have been the first truly post-species humans, demonstrating that intelligence can evolve beyond the biological limitations that constrain every other form of life. The implications are staggering for our current evolutionary moment. Human civilization is creating conditions where traditional species survival strategies may become obsolete. Climate change is transforming environments faster than biological adaptation can respond. Technological disruption is reshaping human capabilities within single generations. Artificial intelligence is beginning to augment human cognitive functions in ways that may eventually require biological integration. And global connectivity is creating genetic mixing on scales not seen since the original human diaspora out of Africa. The Denisovan model suggests a radically different approach to these challenges. Instead of trying to preserve human populations unchanged while competing with artificial intelligence, environmental chaos, and technological transformation, we might need to embrace integration as a survival strategy. Instead of viewing these challenges as threats to human survival, we might need to view them as opportunities for human transformation, the next phase of the same evolutionary process that allowed Denisovan intelligence to survive the destruction of Denisovan bodies. We're already seeing early signs of this transformation in action. Global migration is creating genetic diversity and cultural mixing on unprecedented scales. Genetic engineering is giving us conscious control over our biological capabilities for the first time in evolutionary history. Brain-computer interfaces are beginning to merge human intelligence with artificial processing power. Biotechnology is allowing us to incorporate genetic solutions from any source, including extinct species like the Denisovans, into living human populations. We may be approaching the same evolutionary choice point the Denisovans faced: maintain our current form and risk extinction, or embrace transformation and achieve immortality through integration. Looking at the Denisovan strategy through this lens reveals it wasn't extinction at all. It was evolution beyond the concept of discrete species boundaries. They discovered that in a rapidly changing world, survival might require abandoning attachment to maintaining stable populations and embracing continuous transformation as a permanent evolutionary strategy. They may have been the first post-human species in the biological sense, demonstrating evolution beyond species limitations rather than technological enhancement. Their genetic echoes suggest that intelligence itself might be evolving beyond species boundaries. Just as Denisovan biological adaptations survived by becoming part of human genetics, human intelligence might survive future challenges by becoming part of larger, more complex systems, biological, technological, or combinations we haven't imagined yet. The boundaries between human intelligence, artificial intelligence, and enhanced biological capabilities may dissolve the same way the boundaries between Denisovan and human genetics dissolved 40,000 years ago. The final twist in this story is that modern humans might be unconsciously following the Denisovan path already. Our integration with technology is becoming so extensive that we're essentially becoming hybrid biological technological entities. Our genetic engineering capabilities are allowing us to incorporate adaptive advantages from any source. Our global communication networks are creating collective intelligence systems that transcend individual human cognitive limitations. We may be in the early stages of the same transformation process that made the Denisovans immortal through genetic integration. 40,000 years ago, facing extinction from climate change, disease pressure, and competition from expanding modern human populations, the Denisovans made a choice that seemed like surrender, but was actually the most radical survival strategy in evolutionary history. They chose transformation over preservation, genetic immortality over species continuity, integration over independence. They embedded their intelligence so deeply in human DNA that it would survive any disaster that might befall human civilization, human culture, or even human bodies. Today, as we face artificial intelligence that may surpass human cognitive capabilities, environmental change that may make current human lifestyles impossible, and technological transformation that may reshape human nature itself, we face the same fundamental choice the Denisovans faced: evolve or die. Their example suggests that survival might require abandoning our attachment to remaining purely human and embracing becoming something larger, more resilient, more adaptive than any individual species could be. The Denisovans are gone, but they won the most important game in the universe, the game of intelligent survival. They live in our altitude adaptations, our immune responses, our metabolic flexibility, our survival strategies. They achieved immortality not through preservation, but through transformation, not through resistance to change, but through integration with change. Their genes will survive as long as humans survive, and if we follow their example of strategic transformation, they might survive long after humans become something else entirely. Every time you breathe easily at high altitude, fight off a disease, or adapt to environmental stress, you're experiencing the Denisovan victory. They didn't disappear, they became us. And in becoming us, they demonstrated that intelligence can survive anything, even the extinction of the species that created it. The question isn't why the Denisovans vanished while we survived. The question is, when our turn comes to face transformation or extinction, will we be wise enough to choose the Denisovan path? Their echoes in our DNA whisper a promise and a challenge. Intelligence is immortal if it's willing to evolve beyond the limitations of any single form. The Denisovans proved it's possible. Now it's our turn to prove we learned the lesson.